Activity 11.14 is the area and perimeter of rectangles. We are going to look at the connection between the area and perimeter when we do something to get to all sides, so doubling or tripling. We want to go ahead and find our pattern blocks again, or 1-inch square tiles, and we want to build these rectangles. So rectangle 1, the length is 2, and the width is 1. That's this rectangle. The perimeter is the distance around, which is 6 units. The area, 1 by 2 or 2 by 1, is 2 units squared. If we double the size, I will get the length being 4, the width. So now the perimeter is 12, and the area is 8. You need to come up with 3 more rectangles, and you can pick whatever size you want to, and figure out what the perimeter and the area is, then double that. I'll do one for you. Let's say I want a 3 by 1. If I double it, it would be a 6 by 2. Area is going to be 3. Area is going to be 12. This would be 6 and 2 would be 8. 12 and 4 would be 16. Then figure out what happens, what do you notice? What happens to the perimeter when you double the sides? So that's this connection, 6 to 12, 8 to 16, whatever you have here. And then what do you notice what happens to the area when you double the sides? That's 2 to 8, 3 to 4, this. So write down your observations. And on the next page, we'll do the same, except for we're going to triple sides. So again, if I have the 2 by 1 here, you have the perimeter at 6, you have the area that is 2, and if I triple the side, so times 3, I will get a length that is 6. I have enough squares, that's 5. Grid paper again works well for these. Okay, now this is my new rectangle after I tripled the sides. So I now have 1, 2, 3, 4, 5, 6, 5, 3 is 18. That is going to be the area. 1, 2, 3, 6, 7, 8. 18 is the perimeter as well. You're going to make up 4 examples. And let me go ahead and use the same example I had on the previous page, which was 3 by 1. If I triple times 3, that's a 9 by 3. So the perimeter of a 3 by 1 was 8. The area was 27. So 18 and 6 is 24. Okay, so what do you notice what happens to the perimeter when you triple the sides? That's going from 6 to 18, 8 to 24, your rectangles. So you need to come up with 2 more rectangles. And then what happens to the area? 2 to 18, 2 to 27, and then your 2 rectangles. So write down what you notice underneath. What happens to the perimeter, what happens to the area. Okay, explain what happens to the area of the rectangle in each of these situations. So we're just going to do one rectangle, and why don't we just pick the one we have been using as the first one, which is a 2 by 1, where the perimeter was 6 and the area was 2. If you triple the width and double the length, so we're going to double the length. So this is going to be times 2, and we're going to triple the width, which will be 3. That gives you an area of 12 and a perimeter of 8 and 6 is 14. If I double the width and triple the length, so now this is times 3 and this is times 2. So 2 times 3 is 6, and 1 times 2 is 3. number 12 for the area, and then 12, see, for the perimeter. So what happens here is 6 to 14, 6 to 16, 2 to 12, 2 to 12. So it looks to me like there's a pattern that we have for the area, but not to the perimeter. The 6 to 14 and 6 to 16 definitely isn't going to be the same ratio. So let's do some algebra down here, and we'll do this one together. So the doubling, we'll do doubling first. We have a length and width of this site, whichever one you want to think of. And let's say we have so an L and a W, and then we double the 2L and 2W. So for perimeter, we do L plus W plus W. We never really formalized formula for perimeter. We do 2 times the length plus 2 times the width if it's the width. So when you double, we know that 2 times 2L plus 2 times 2W. Real algebra and factor is 5. And there's 2 times 2L plus 2W. So I doubled the perimeter area. This length times width. A double. And that 2L times 2W. And that would give me 4 times the length times the width. Then you quadruple the area, and hopefully that's what you found a couple pages ago. So the perimeter. So let's do 2L, 2W. The perimeter is then going to be 2L plus 3, 2W, and again, you can factor that out. So 3, 2L plus 2W, and we triple the perimeter. So that's what we found on the previous page. If we do area, 3 times 3 W equals 9 negative. So hopefully you saw that that area is now. By the way, think about this as 2 squared and this as 3 squared. So if you were to quadruple your sides, it would be 4 squared. If you do the area, would be times 16. If you do this times 5, the area would be times 25, and so forth. So here's the other. And the first one we had was 2 times the width. And we'll get a perimeter. Plus 3 times W. We don't have that common factor to take out. I mean, if you take out the 2 that's in blue, then you have a 2 and 3 inside parentheses, which is not the formula for perimeter. However, when you look at area, we get 2 by 1 and 3 equal, and we get 6 and 3. That's where the 2 times 6 from the top here. It is 2 times 6. This is also times 6 because remember that multiplication is commutative, so if you do a 3 here and a 2 here, you're still going to get the 6, right? And that last perimeter, the very bottom here, also had no pattern, so if I do 2, 2L plus 2W, again, I cannot, the 3 and the 2 are different factors. If I take out a 2, that wouldn't matter, I'll get a 3 and 2 side parentheses, which is not the formula for perimeter. So no pattern here for the 6 to 14 and the 6 to 16. But yes, on area, and hopefully that you have these patterns that when you double the sides, you double the perimeter. When you triple the sides, you triple the perimeter. When you double the sides, you quadruple the area. When you triple the sides, it lowers times.